Hello guys, this is your teacher Claude. Today I want us to introduce something which is called complex numbers. We're going to take more time to talk about these complex numbers. I hope that you have subscribed because you know that these things of mathematics is very important. I don't doubt that also you are going to comment to add ideas about this content, about this topic of mathematics which is called complex numbers. And we are going to share, we'll be sharing ideas every time, and your ideas will be dropped in the comment. If you like this video, you can click like, and if you like any other ideas like the previous topics about the differentiation, you can click like, there's no problem. You can subscribe, you can comment, and also you can share to the people that you think that they need this content. Why do we need the complex numbers, first of all? Why do we need the complex numbers? Normally, we have many set of numbers. We have seen many set of numbers like your numbers. So, there is a problem now. We know that there is no number which can be squared to give a negative number. No number which can be squared to give a negative number. Or we say that the square root of a negative number does not exist. Where we say that, where we can see we need to find the square root or the any root of a negative number. That is where we bring this thing of complex numbers. How do we bring it? A set of complex numbers. This set, when you are trying to find the square root or the any root of this negative number, when n is even, automatically we introduce what we call the imaginary number. For example, let us have to find the square root of negative 4. We are going to see what we call the imaginary number and where it comes from. When we want to find this square root of negative 4, we see that it is square root. When we try to find the factors of negative 4, we can have 4 times negative 1. We know that this negative 4 is equal to 4 times negative 1 or negative 1. And this is, when you go with the properties of the multiplication in a root, this is the square root of 4 times the square root of negative 1. I hope that we agree with this. Negative 4 is equal to 4 times negative 1. Now, for every negative numbers, the problem is that one is this, which is square root of negative 1. Then we say that the square root of negative 1 is the imaginary number. We call this the imaginary number, where we say that then such that this square root of negative 1 is equal to I. We use this I to say that it is the imaginary number, where also for the engineers, you will see, for those who are doing engineers, instead of saying I, they use J. Root of negative 1 is equal to J. They use J as the imaginary number. So now, hope that now we are understanding, or trying to understand what we call the imaginary number. The imaginary number comes for helping us to introduce the square root of negative number to be possible. And then we can say that, according to this, we can say that now the set of complex number is the combination of real number within the imaginary number in 2 dimensions. Now, we don't go only in 1 dimension, but also we can go in 2 dimensions. When you combine a real number and imaginary number in 2 dimensions, we have what we call the set of complex numbers. How can we use this? How can you apply this? Automatically, we can apply this when we're trying to evaluate like different expression, like a different expression. Like when we're trying to evaluate the square root of, for example, square root of negative 9. You can say it's equal to what? Square root of negative 9. We see that this is equal to square root of 9 times negative 1. And this is equal to what? Square root of negative 9 is equal to square root of 9 times square root of negative 1 And according to this, we can say that this is equal to positive or negative 3i, because this one is I. Because this one is I. So in complex numbers, we can say that this positive or negative, square root of negative 9 is equal to positive or negative 3i. Then for this one, we can have other property where we can say that if square root of negative 1 is equal to I, also I squared is equal to negative 1. Can have this property. And this is the introduction about this imaginary number. You can have another example here, how we can apply it. Simplify it. 3i squared positive 3i squared, like this. This is equal to what? What do you think about this? Okay, this one, automatically we have a square at 3, which is 9, and the square at I squared, positive 3 times I squared, know that it is negative 1. I squared is equal to negative 1. Then this is 9, I squared, and I squared, we know that it is negative 1, then negative 3. 3 times negative 1 is equal to negative 3. So this is a negative 9, negative 3, which is equal to negative 12. This is an example here. You can have another one, negative 8, I positive negative 4i power 3. You think this is equal to what? This is equal to negative 8i negative this negative when it is powered of 3 or when it is powered with all the number to continue to be negative, then 4 power 3 it is 64, then I power 3, and we are going to find I power 3, negative 8i, negative 64, I power 3 is negative I. How do we get this? We can get this by using I squared times I. Know that I power 3 is I squared times I, and this is equal to negative 1 times I, because I squared is negative 1. So this is negative 8i, positive 64i, and this is equal to positive 56i. This is the value of this expression. Not only this, we can also use this kind of expression when we are trying to solve like a quadratic equation which is not solvable in a set of real numbers. When, for example, those kind of quadratic equations which are not equal to 0 in a set of real numbers, then they are equal to 0 automatically in this set of complex numbers. Then you can use this property of I when you are trying to solve this. We have x squared plus 64 over 25 equal to 0. When we are going to solve this, we take this to this part. We know this one. So we get x squared, which is equal to negative 64 over 25. And automatically we need to put square root to both sides. When you put square root, this square is eliminated. We remain with x, which is equal to, then this is 64 over 25 times negative 1 square root, like this. Because this is negative. This is equal to square root of 64 over 25, then times I. Square root of negative 1, square root of negative 1. So this is it. Square root of 64 is 8. Square root of 5 of 25 is 5. So it is positive or negative 8 of 5. Square root of negative 1 is I. This is the value of x. You can say that x1 is equal to 8 over 5i, and x2 is equal to negative 8 over 5i. This is about the properties and some theories about the imaginary number. Then next time we can talk about how we can add and subtract the algebraic form of complex numbers. Remember to subscribe, remember to hit the notification, remember to add a comment about what you have seen today or what you want us to talk about. And even remember to check my videos. There is a previous videos about differentiation, about solving like linear, exponential, and logarithmic equation. So you can check all those videos are there. Thank you very much.